In the ideal world, you're going to start on a new project, which has clearly defined features, requests, specifications, 100% test coverage, and you can happily write the tests for all your code without having to worry about changing it or making it testable, refactoring it, etc. This will probably not always be the case. You will have to be prepared to take on the challenge of tackling the less than ideal environment. Adapt your workflow and evolve the code base. Obviously, you should decide first on the framework that you want to use for testing. This will depend on the kind of technology that you're using and your previous experience on the matter. For example, in .NET country, the most used frameworks are XUnit and NUnit. If you're working with JavaScript, you're going to have to look into Jasmines. Probably there's some other frameworks as well. So a very common problem with projects that are not designed to be testable is that they're too tightly coupled, especially with the database. The code will depend on having a database connection and is not designed in a way that it will work without several calls to the database. Unit tests are by definition tests that will only test small separated pieces of the software. It will never hit the database in any way, or should not, and if it's properly set up in a separate project, it won't even have access to this database, so it will just throw errors instead of running the tests properly. The solution to this problem is or will require refactoring, which should be done progressively, probably ongoing for a couple of weeks, days, months, whatever, to a repository pattern, for example, and dependency injection. Got a small example here. Let's say you want to test this method that will index all your contracts. What you see here is the variables. Contracts is gonna, through the contract class, gonna call the getFlight contracts, which will contact the database and return a certain list of contracts. Then it will do its various complicated calculations and return it. If you're going to try to run this in tests, it's going to fail. You can't connect to the database, so there's no way that you can actually test this, so you're going to have to come up with another solution. Like I said, my solution would be a dependency injection. This is basically the same method, but here we're going to inject a repository. And it's actually going to work exactly the same way as before. You just call the same database connection, going to give it back the same list. It's basically nothing has changed, except you have to give in the repository in the parameters. Usually this is part of a larger class, and you might have given the repository in through the constructor. This is a more separated example. I'll show you how those repositories will look, because in the actual code you're going to have to use an actual repository that will connect to the database. In the test classes, you're going to have to mock this repository. It's going to be basically fake code that will just return you whatever contracts that you want. This is the real repository. Small note, this should actually inherit or apply the interface iContract repository. So it's missing here. And basically this calls exactly the same code as before. It's gonna use this contract class or whatever class you have in use for the database connections, and it's gonna inject this right in the repository so that you ensure it works in the same way. Over time, you're gonna want to come up with a better solution than this, but if your application is full of these kinds of database connections, this is a nice way to work yourself through this flow. This is the mock repository. It's going to have the same methods, and in this case it's more of a custom fixtures. If no one's familiar with fixtures, it's kind of a fake data entity that you will use for testing. It will automatically fill up the contracts with random data in this case. So here I have decided the getFlight contracts will return a list of 2 random contracts, and the test will behave how they should. So about that example, I'm gonna have to come back a bit to this after this. What I wanted to say is there might be other problems, likely also caused by too tightly coupled codes, and you have to refactor this, but you should not just decide, yeah, now I want to do test-driven development, I have to refactor my entire 1 million line code application just so I can test it. It's not going to be a good idea. You're going to have to do this progressively. You want to test this method, make sure this implements the mock repository, and keep it at that. If you want to test another part of the application later on because you have to add functionality, that's when you're gonna switch that part of the code around as well. So about refactoring, of course, if possible, you want to write unit tests before refactoring the code so that you know it's still working after the refactor. But if you're coming into an application that's not designed to be testable, it might be very hard to get it done, but it should definitely be a priority.